Combustion and flame. Combustion is an exothermic process in which a substance completely burns in the presence of oxygen or air, giving out energy in the form of heat and light. Flame is a region where combustion or burning of gaseous substances takes place. Most of the combustible substances on burning produce a flame. Combustion. If you burn magnesium ribbon with the help of forceps and burner, you will find that it burns with a blinding white flame and forms a white residue known as magnesium oxide at the end. This happens because of combustion. When oxygen is scarce during burning, carbon monoxide is produced. Oxygen, fuel, and heat are needed for combustion to continue. When any of these is removed, the burning stops. During the process of combustion, light is also given off, which can be seen either as a flame, combustion of petrol, or in the form of a glow, combustion of red hot coal. This process of combustion may be slow, as in the case of slow-burning candle flame, and explosive during the combustion of a mixture of petrol vapor and air. A material is said to be combustible if it burns completely in the presence of air. If it does not burn completely, then it is said to be a non-combustible substance. 3 conditions required for combustion: presence of combustible substance or fuel, presence of supporter of combustion, oxygen of air, attainment of proper ignition, kindling temperature. Ignition temperature. You might have heard of forest fires when dry grass catches fire of its own during extremely hot conditions. But a matchstick does not catch fire on its own. Sometimes we use paper, straw, or kerosene oil to start a fire in Angeti. Wood shavings burn easily in comparison to a log of wood. All these different substances catch fire at different temperatures. Actually, there is a temperature at which a substance catches fire. Thus, the lowest temperature at which a substance burns is called its ignition temperature or kindling temperature. The temperature of combustion is highest temperature reached during combustion. The heat of combustion is the total amount of heat given off when a substance burns. It is measured in calories or joules. As long as the temperature of a substance is lower than its ignition temperature, a combustible substance cannot catch fire of its own. Due to this reason, we have to heat any combustible substance before it catches fire. A matchstick is struck against a rough surface before it catches fire. Inflammable substances. The substances having very low ignition temperature that catch fire and burn easily with a flame are called inflammable substances. Example: LPG, CNG, petrol, alcohol, diesel, etc. are inflammable substances. Fire. Fire is the heat and light that comes from burning materials. A material that burns is one that can combine quickly with oxygen. Burning is a process of rapid oxidation and is also known as combustion. Some substances combine with oxygen very slowly. During this process, no light and very little heat is produced. Rusting of iron is an example of slow oxidation. Types of combustion. Combustion can be broadly categorized into 3 types: rapid combustion, spontaneous combustion, and explosion. Rapid combustion. We see that LPG burns even from a spark of a lighter. Such type of combustion which occurs rapidly and produces heat and light is known as rapid combustion. It suggests that substances which undergo rapid combustion have low ignition or kindling temperature. Spontaneous combustion. Spontaneous combustion occurs when substances begin to burn without having been ignited by a match or some other burning object. Piles of oil-soaked rags or coal containing moisture sometimes begins to burn without having been ignited. This type of combustion is caused by the rapid union of oxygen with hydrogen or carbon in the oil or coal. The rapid reaction raises the temperature above the kindling point and the substance begins to burn. Explosion. A sudden combustion reaction in which large amounts of gases are evolved along with heat, light and sound is called an explosion. Many explosives, called low explosives, are capable of undergoing relatively slow combustion under suitable conditions. High explosives produce uncontrollable blasts. The first low explosive was gunpowder, and the first high explosive was nitroglycerine. Complete and incomplete combustion. Complete combustion takes place in the presence of sufficient air or oxygen, resulting in the formation of carbon dioxide, water, heat, and light. Fuel plus O2, sufficient supply, is equal to CO2 plus H2O plus heat plus light. Incomplete combustion takes place when air or oxygen is insufficient, resulting in the formation of carbon monoxide, soot, water, heat, and light. Fuel plus O2, insufficient supply, is equal to CO plus H2O plus soot plus heat plus light. That is why a fan is needed in big hearths and furnaces. Flame. Many of the substances burn with a flame while others do not produce flame during combustion. A flame is produced when combustible substance is in the vapor state and burns strongly in the presence of air. Studying candle flame. Light a candle in the dark and notice the various zones of colors produced in its flame. You would notice that the candle has 3 distinct zones or regions. The outermost zone A is blue because there is supply of oxygen of the air is adequate, resulting in the complete combustion of wax. This is the hottest part of the flame. The middle zone B is yellow because of less supply of oxygen, which causes the rising of unburnt carbon particles. This causes glowing of unburnt carbon particles, making this region to appear yellow. The innermost region C is black because of the presence of unburnt carbon particles. This is the least hot part of the flame. That is why goldsmiths use the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Fuels. The substances used for producing heat energy are called fuels. Some examples of fuels are coal, coke, wood, charcoal, natural gas, and most of the petroleum products. Fuels are put to the following use. For cooking food in our homes in the form of kerosene, coal, liquefied petroleum gas, LPG, etc. For transporting men and material by road, sea, and air. For heating boilers in the industries. For generating electricity in thermal power plants. Classification of fuels. On the basis of physical state, fuels are categorized into three types, such as solid fuels, the fuels which exist in a solid state at room temperature, example wood, coal, charcoal, etc. Liquid fuels, the fuels which exist in a liquid state at room temperature, example kerosene, diesel, petrol, etc. Gaseous fuels, the fuels which exist in gaseous state at room temperature, example LPG, CNG, natural gas, etc. On the basis of origin, fuels are categorized into two types, such as natural or raw fuels, the fuels which are used in the same form as they occur in nature, example wood, coal, petroleum, etc. Manufactured or processed fuels, the fuels which are prepared from natural fuels by various physical and chemical processes are called manufactured or processed fuels. Example charcoal, coke, petroleum, etc. Harmful effects of burning fuels. Due to the non-judicious use of fuels, many harmful effects are caused both to the environment and the human health. Carbon monoxide. It is a poisonous constituent of car exhaust fumes. It forms a stable compound with hemoglobin in the blood, thus preventing the hemoglobin from transporting oxygen to the body tissues. Carbon dioxide. Burning of fossil fuels and clearing of forests contribute to the rising level of carbon dioxide, which has caused global warming. With increase in temperatures, many species of trees of the temperate forests can become extinct. Alternatives to conserve fuel and reduce pollution. Pollution caused by burning diesel and petrol can be reduced by using CNG, compressed natural gas, and LPG, liquefied petroleum gas, where CNG is not easily available. The use of CNG and LPG lowers the emission of harmful products to negligible amounts. Some ways to check the wastage of fuel. Switch on the burning device after placing the container on the burner. Reduce the flame through control knob when container gets heated enough. Use pressure cooking devices containers whenever possible.